Good morning. So, as of we are discussing about Apache Hive. So, what is Apache Hive? It is a one structured query language, and it is simply called HQL, Hive Query Language. So, where we are going to be deal the how to maintain and monitor, and even we can organize data in a efficient in enterprise data warehouse. So how we are going to be keep the data in warehouse such that the data is going to be used by the enterprises efficiently. So for that we are simply like SQL, here also we have some statements, Hive QL statements, that is we can simply call it HQL statements. So by using this we are going to be organize and handle the data in a structured manner, so that such that the data is going to be kept in warehouse in a structured manner. So once the data is going to be kept in a structured manner, then it should be properly used by the customers or users in the organizations or outside the organizations who are dealing with that particular data. It is very easy to, even if not only for that, it is going to be used whenever we are going to be perform map reduce operations on that particular data that are easily um, organized and easily shown the data at a user's customer. Okay, so for that here we have some of the maximum topics are we are covered last few classes. So even I need to give an overall about Hive and how the query language is implemented in the Hive, and how it will be create database and how to write the tables and how to drop the tables. What are the various operations are on the tables? So such types of comments how we are going to use, that we will discuss in one or two classes. So initially we know that all these HDFS applications, whether it is Pig, Hive or others are there. So others, that is Pig is initially it is developed by Yahoo and hand over to others. But this is Hive is started at Facebook and later it is hand over to Apache only. So the data was collected by nightly thrown jobs into Oracle DB. So how we are going to be collecting the data? So the data how we are going to be stored in the database, Oracle database DB. So ETL, so enterprise oriented database via handed coded Python. So how we are going to be translated this data in a useful manner. So grew from tens of GBs in 2006 to 1 TB per day. New data in 2007, now in 10 into X. So we know that the data uh, rapidly increasing nowadays. So we know that up to 2010, before how much data is there, total data in it, twice of data is generated in the last few years. So that is the simple meaning that see that tens of GBs in 2006, now it is 1 TB per day. New data in 2007, now it is more than 10 times of that one. So 10 into X means that is the 10 times of that one. So once the data is generated abnormally and it is not is going to be handled properly, so then it is waste of doing collecting that data. So that's why if we are going to be collecting the data, how far we can use the data in efficiently. Okay, so that is it. So subscribe the server types and it is the two-tier or three-tier architectures we are going to use. Then MySQL server types. Then both of them we are going to be collect the data collection servers. We are going to be collect the data, and we are going to be creating Oracle database. The database, once the database comes into a picture, means the data is arranged properly in a tabular column. So such that manner, if table may contains index, Through that index, easily we can identify the data from that database or data set, whatever it will be created. So if the data is increased rapidly, is more than 10 times. So if the data, how we are going to be collected and how we are going to be managed. The simple SQL statements, we are not going to be deal with the large number of data. So we can have very simple 100 and 1000 rows of data. We can easily do it on SQL. So if it is more than that, then we are going with these Hadoop applications such as Hive. Okay. So these are the Hive applications are there. So log processing. What is the meaning of log processing? So generally we enter into the lab, we can call, so all of you enter your name and entry time in the log. I will remember log. So that is the log process. That is the in and out times. What time you are in and what time you are out. And if the data is produced that time, so how much data you have produced. So how much time you have produced the data and where you have stored. And that simply we can have a name node information. So what is the name node called? So in Hadoop we have a name node and data node. So what is the meaning called name node? Name node contains the information about when it is created. So the description about the data. So where when it is modified, when it is created, when it is updated. So every details. No? So that is for log processing we are going to be use these Hive applications. Then text mining. So even the various ways of we are generating the text here. So text format, C format, ORC format, so many things are there to handle the text data. So that is we are doing a here text mining. That means so generally the text files are taking long time to retrieve and long time to process. So in order to overcome this one, we are going to be move to various other file formats such as ORC formats and RC format and the input output formats. So where we are going to be perform on input output formats from record to input output format by using serialization and deserialization concepts. So how we are going to be convert from record to input format or our record format to output, how we are going to be performed. So by using these text mining concept. Then the another one is about documentation index. So what is the meaning called indexing? So if, for example, if you have 1,000 pages of book is there, so definitely if I ask you to set something in the book, so what you are going to be doing? You cannot go directly with the book page by page reference. Definitely you have to go with index. So through that index, we are going to be find that particular concept in that book. So by that we can easily recognize that what is in that particular concept, and we can easily find that concept in that book. So in order to search by page, yes or no? If I am not giving any index to that particular book, if I ask you to set what you are going to be, so page 1 to page 1000, we have to set each and every page. So that word may comes in first page or second page or 500 page or 900 page, we don't know about that one. So if we have a proper indexing about that one, then we can find that concept easily in the text. That a document indexing also is provided by the Hive. Then customer facing business intelligence. So for example, Google Analytics. What is this customer facing business intelligence? What is the business intelligence here? So we already know that what is data mining and business intelligence subject is. So what is the business intelligence? So we have a large number of amount of data in there, and we done some mining concept on them. So please be remember that the starting onwards we are saying that data mining is a solution for big data analytics. Big data analytics is a problem, and data mining is a solution for that. Okay, have you remember everyone? Big data is a problem, and data mining is a solution for that. So how we are going to be deep dig into the data, and finally we are going to be search the useful data from out of large pool of data. So that is the main. So how we are going to be taking, so business intelligence, how we are going to be take this business intelligence means, so if the data is there, how we are going to modify it, and we are going to be segregate the data into different various uses, and how we can use in a proper manner. So if the, in the data we have a large different sets of informations are there, but one and the customer needs only a proper information about the product. So it may be proper need for the data. So he need to process that one. He don't need the remaining other things. So what is the exact data he need? That data is to provide with the. So even I will show you what is this Google Analytics. Next one is about predictive modeling and hypothesis testing. What is the predictive model? Predicting what is, we have to predict. We are going on the road, so we need to predict. The road may divide into two parts, so we need to predict that. So if one way is from X and another way is Y. So which one we have to predict and we have to reach the destination. So another one further related only hypothesis testing. What is the testing? The name itself there, test. So we have to pass the parameters. Through that we can going to be get an exact result or not. So that's the testing purpose we are going to be use this application also. So I will show you some of simple Google search about this Google Analytics and predictive analytics and hypothesis testing. You can simply see that. See this Google Analytics. What is this Google Analytics? So we can see the information here in Wikipedia. So Google Analytics is a web analytics service offered by the Google that tracks and responds the website tracking. So website traffic, we are going to be observers. So website traffic. So I think now it is visible. So see, whenever the concept analytics comes into a picture, definitely we have seen that some of the bar charts and pie charts are going to be make a difference. So Google Analytics is a web analytics service offered by Google that tracks the reports of website traffic, and currently it's which platform inside and the Google marketing platform brand, and Google launched the service in November 2005 after acquiring for Google. So these are the informations we can perform by using Hive, Apache Hive. We can do this analytics. So how we are going to be do and how we are going to be track the information. Okay. So analytics is, let's measure the advertising of ROI, where we track the flash videos and social marketing on the sites and applications. How we are going to be. So even we can see some of the pictures over here. See that how the Google Analytics, for example, actionable data and data actionable data, how it is. So total data, how we are going to be seeing that Google Analytics. So various analytics in simple meaning is we are going to be seeing the data in the visible format. So how we are going to be see the data. See that? Okay. So such type of analytics is going to be performed on Google, that we are going to be seen on the other user end. So Google Analytics has various properties. These out of these properties, all those things, we are going to be use this Hive is going to be helpful for these applications. So then another one is about, we talk about predictive analysis. What is a predictive analysis? So predictive analysis, predictive modeling uses the statistics to predict the outcome. So how to predict the outcome? So finally, for example, if we are going to be do this particular process, before itself we are going to be confirm that what is main meaning, what we are going to be get the outcome of this one. Then we are going to be do this one. So often, most often the event one want to predict in the future. So what will be in the future if I am going with this one? So simple, for example, if I am going to be select a particular branch, or for example, if I am going to be select a particular job, for example, in a software industry, we have various core technologies are there in different companies. So for that, we are going to be analysis the future itself. Future analysis. If I am going with this, what's my end? Then what I am going to be getting? What much salary? How we are going to be predict this one? So may you are going with some company profile or some user profiles you are going to be checking. So what is the statics, how they are going to be followed. So how the salaries are there and how they are going to be take care about the employees, and what are the offers and benefits are provided by the employer to the employees. So such type of things we can think before itself, and we are going to be select a particular thing. So, but the predictive model cannot be applied for a type of unknown events. We cannot, regardless of when it is occurred. So, see that the predictive modeling is also called a predictive analytics. It is a mathematical process that seeks the predictive future events, outcomes, analysis the patterns that are likely to be forecasted in future results. So everything which we are going to give some algorithms we are going to be trying. So I think we heard some sentiment analysis, all those things we may heard that, no? By the, for example, by posting your comments or posting your own messages in the Facebook or Twitter or other any social website. So the people who are sitting in the background, they can see your sentiment by sending your messages and seeing your comments. What is your present mood and how you are feeling that. So everything they are going to be predict. That is a one nowadays very popular in the sentiment analysis. How we are going to. So based upon your text messaging, based upon your activities, they are going to be finding things. That's it. So then another one is about hypothesis testing. So here we can see what is the hypothesis testing. Series here, hypothesis testing is a process of using a statistical test to determine if the observed difference between the two or more samples is statistically significant or not. So what are the parameters we are going to be considered to process that one? So that things are going to be significant, that is important or not, that we are going to. So it may be sometimes it is a null hypothesis or null means both are things are not are going to be useful for better testing also. So it is started that assumption that there is no difference between such testings are difference due to maybe a random changes. So if the changes is done, maybe that one we have some differences, but uh, overall meaning that we basically we don't have any changes in there. So if anything is changes, that time it is going, the difference is going to be happen. So that time also we are going to be say that there is a null hypothesis. While the alternative hypothesis is a statement that there is a true differences. So with the help of hypothesis testing, we arrive at one of the following conclusion. So fail to reject the null hypothesis and reject the null hypothesis. So that is accepts the null hypothesis, accepts the alternative hypothesis. That is the meaning of that. So that is means hypothesis testing means we are going to be taking two different parameters or two different way of testing that one. So which one is a better testing to go and see the differences? So if it's no differences and if differences is there, what is the alternative things we have to perform? From the practical point of view, hypothesis testing is allows to collect the sample sizes, make the decision based upon the facts, and takes way to the decision based on the guts feeling, experience, or common sense. So the various things are going to be take as the parameters. Maybe based upon his experience is going to be selected, and based upon his feelings is going to be common, and common emotions, and what are the things. Everything is going to be dealt here. So these are things are going to be considered as a various parameters. So you have a statistical proof for whatever you feel and think and write. So that is a simple proof for processing on this. An application-oriented questions on a topic along with the responses seen below. The best answer was provided in the something in 2017 one scientist is given a. So how we are going to be seen in a better manner. So which one is a good decision? Which one we can process for future analysis? Which one is better to go with the best one? So how means again there is there based on their own decisions. So we are going to do. So this type of Google Analytics and predictive analytics and hypothesis testing. These are the testings are important to these Hive applications. These are the Hive applications, basic Hive applications. So then, what are the Hive components are there? So we have a shell. By using a shell means we are going to allow the interactive query like MySQL shell connected to a database. It supports all VDBC clients and drivers, session handles and fetch and execute, and compiler pass, plan and optimize. So parser and plans and optimize how we are going to an execution engine. You know what is the DAG, direct acyclic graph stages are MR stages and HDFS are metadata stage. So we are going to be MR means map reduce. So don't be confused. MR map reduce are the metadata processing. So we are going to be performing execution engine. So these are the main components of Hive. So shell how to interact the queries and drivers how to handle that queries and to also that is it is going to be fetch and it is going to be how to execute that one. So have you remember the uh, Hive execution step, working steps, the 10 steps is there, no? So there we have interface to drivers, drivers to compiler, compiler to metadata, and the same back process. And the compiler gets the information from the metadata, it's submitted to the drivers, and drivers set to the data to the execution engine submitted to the map reduce operations. Once it is needed a physical data, again it is back at 7.1 step I have shown you. Know. So it is back to the metadata and it's going to be collect the physical data from the meta store and it is saved into the map reduce operation. There we have a task tracker and job tracker to perform the operation continuously. So that is the information. So that is the same process. This is the component shell and drivers, compiler, and execution. A shell is nothing but we can call as interface here. So metastore. So remember there are 10 steps. So if you want, I will show you again. So if you want to remember these 5 components, you remember the 10 steps you can. So if you want, you can write them. First step is about we need to interface is there from interface to drivers. That is the first step. Then drivers to compiler. The second step. Then compiler to meta store. That is the fourth step. Then we can back to metastore to compiler. So once it is compiled, it is a checks is done properly, then it is back to the. Then it is transferred to the drivers. Then compiler to drivers. Once it is transferred to the drivers, then it is sended information to the execution engine. That is the execution engine. In that engine, it is going to be transferred the queries into the map reduce operation. So once map reduce operation is going to be checked and it needs some physical data, that data is going to be getted from the metadata service and it is stored into the data node. So we have two nodes now, name node and data node. Name node contains the information about the node. The data node contains the physical data which presented to meta. So it is going to be getted from. Okay. So that is going to be executed and there we are going to be perform operation and finally we are going to be reduce output of that particular query or whatever. So their metastore schemas, location, HDFs, and serialized, deserialized operations are there. So that is reading and writing rows. That is a serialized, deserialized. Object to text file and text file to object, how we are going to do. So another one is about data model. So we have a table, the typed columns. So int, float, string, and boolean. So these are the table columns we are going to be mentioned. These are the information contains the table column may contains int, float, string, double, boolean, and also the list and maps. So for Johnson like data, so Johnson provides JSON provides this list and map information and partitions. So how we are going to do, for example, to range a partition table by date. So how we are going to be joins. No? So there we have partitions and we have buckets. The hash partitions with ranges useful for sampling and join optimization. So that is how we are going to be joins and how we are going to be take sampling out of that table. Then metastore. What is this metastore? So database. We can simply call it database. Namespace contains for a set of tables. Namespace contains for the set of tables. So how we are going to be store the data in a proper manner. Then another one is holds the table definitions. We need to hold the table definitions. So column type is what, physical layout is how it will be. So all those information about the data we are going to be dealing with the metadata. So general SQL is going to be talking about the database we have heard up to now. So here again the data contains about the large data. The data contains about the metadata. We know that what is metadata? Data about the data. Data about the data. So that is a thing known as hello. Second. Second. Okay. So how in a simple database we are going to be talk. Same way here also we are going to be know about the data about data about data, how we are going to be process that data information is going to be used to very high level, that is the whole information, column information, layout information, all those information it contains in metastore. And the partition data, if any tables are joins or all those things. Implementations how we are going to be done. So we already seen that nearby and MySQL and many other relational database systems how we are going to be JDBC and ODBC connections how we are going to be done. All those information is going to be. So what is the physical layout here? Warehouse directory in HDFS. So that particular warehouse directory means, what is the meaning of directory? Create directory, CD. So generally we are going to be use whenever we are going to be type a program CD file name that we are going to be transferred our files into the directory. What is the meaning of that? The folder which we contains and it has some linkage. Through that link we can access that. So directory information means, so where it is available, for example, C slash bin folder slash HDFS folder slash, like that we are going to give the information like URL. Same way in physical data, how we have a directory. So if you want, I will show you, for example, if I want to set something data from my system. So say this, for example. So for example, here, this is about my computer, my screen is visible. Then I'm going to semicolon, some there, for example, we have academic year and we have PTA and we have again personal notes and we have, so for example, if you check this one, So this is the directory. For example, if I want to take something, so for example, BDS syllabus variety level. So if it is take this one, if you go to properties, so see that I think it is not visible. It is visible. So properties we can see that we can see uh, where it is available and all those things. So see here the location. So see that if you copy this location directly and we can open, for example, we can directly click on my computer. You can simply so paste, for example. So if I'm going to be pasted here directly, I can go to the particular. Simply how we are going to be use an URL. Same way here we can use this one. So this is the directory services how we are going to be. So if the physical data is available, definitely we need to know how to give a directory or how to give an indexing also. So that information definitely we need. Okay. Okay. So physical layout. For example, see that user Hive the data warehouse. See generally how it is available in user and in a Hive folder and it contains some data warehouse. So tables stored in subdirectories of warehouse. Tables are stored in subdirectories of warehouse. So again warehouse we have some of the subfolders are there. So in tables are stored in the partitions from the subdirectory tables, the actual data in a flat text file. So actual, for example, wherever I given that link now, for example, some e colon slash cr or something again colon. So where the exact data is available in a particular file which contains a class. So that file only, that a flat file. So later on, we don't have any extensions for that. So finally, we have a flat file. That file contains the actual data. So control char delimited text and sequence files. So this is how we are going to be divide the columns in the table that the information we are going to see about. With custom serialized serialization, can use an arbitrary formats how we are going to use. So these are the physical layouts of it. Then starting with the Hive shell. So shell, what is the shell means? How we are going to be execute the information we are going to be used. So start at a terminal and run. So generally we are going to be terminal and run. So if the terminal is starting with like this dollar symbol with Hive, then we have that is should see the hello 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 class lo పరిచయం should see the format like how we are going to do. So Hive greater than symbol. If it is starting with this greater than symbol, so the same way in pig where the grand shell operation we have pig is greater than symbol, it is going to be started. No? Same like that. Here we have a Hive and we are going to be series. So creating a tables, how we are going to be creating once it is started with Hive, show the tables. So how previously we can select the star from table and SQL however. So same here we can show the tables. So it shows the table. Then how to create a table? Create a table, and I'm going to be create a table Shakespeare. I'm going to be create a table name as a Shakespeare. So frequent int and word string. So two columns. Row formatted is delimited fields and terminated by /t. It's stored as a text file. So I'm going to be created one table. The table is going to be stored as a text file and it contains the two fields. That is one is frequent for each field and another one is word. Frequent is a int type and word is a string type. And how, for example, if I enter one row, for example, one first row I'm going to be enter the data as, for example, integer I'm going to be enter, for example, 0 9. If I am giving /t, then if I enter another data. For example, word is about for example any book of Shakespeare if I write something. So once it is reading the data, so 09 for example particular word, and by slash t it is taking as the next word is about the next column. Okay. So like that it is going to be divided by using, and it is stored in the text. So hi. So it describes the Shakespeare if I give like this, how it is going to be seen the overall data at the visual end. So generating data. So here the let's go the word and frequency of data by the Shakespeare's data set. See that Hadoop, jar, we have a Java file, that is a jar file, and slash Hadoop home and Hadoop star example jar, and G representations input, that is a one command. So input Shakespeare underscore frequencies. So where we are going to be get all the frequencies. That is means all the numbers which already we know that the frequency is integer numbers. No? That integer numbers data, what it contains, the information, all those information it will show. So like that we are going to do. So after that we are going to be load the data. So remove the map reduce jobs. Then we are going to be use this remove Hadoop FS files system, that is remover. So RMR is a remover, Shakespeare's frequency and logs we are going to be. So we already said that the Hive is the one of the application is the log process. So we can remove and delete the log process. Load data set into Hive. Load data set into Hive. How we are going to do? So load data path. So Shakespeare's underscore frequency into table of Shakespeare. So this is the data set Shakespeare data set that I am going to be stored in the Shakespeare's table. We already created no table name as a Shakespeare's, where we are going to be given as a frequency as a integer and word as a string. So there we have a whenever we can get a slash v, then automatically it is going to be written to the next row like that, which is going to be taken. So in the text file how it is going to be read. So selecting a database, selecting a data, how we are going to do. So simply we know that SQL statement select star from Shakespeare and limits up to 10. So limits means from how many rows we need to show. So that limits we can mention the 10 rows. SQL star from Shakespeare where the frequency is greater than 100 and short by the frequency and ascending order limits to 10. So again, we are going to be here, how we are going to be show the table. So select star from Shakespeare means it shows all the whole table. For example, it is how many lines are there, we don't know about it. So if you want to limit to 10 lines, or if you want to take more than 10 words, how it will be, then we need to ascending order and limits to 10 again. So out of 100, we are going to be take a 10 limits. At that 10 limits also in some ascending order. So in various ways how we are going to sort out the data and how to show this. So the most common frequencies, again we can use what are the common frequency numbers we are used most of them. So select frequency, count 1 as F2 from Shakespeare's group by frequency sort by group by F2. So description description, that is the DEC limit up to 10. So most frequency how we are going to be find, and that means most of them who are taken that words or who are taken the novels whatever it may be. So that novels who are read more frequently, that data also we can group it here and it shows on the. So Hive explains the select frequency in the count as F2 and from the Shakespeare group and sorted by F2 and kilometer units is 10. So like that we can use select and we can use explain select also. So all this information. So still we have joining tables, all those things. We'll see in the next class these joining tables. Still tell me anyone having doubt about this one. So tomorrow onwards I will show you how to process these tables, same like SQL statements, how it will be and how we are going to be processing. So that's only I told you yesterday. Please go through the TCL and all the comments